Hey everyone, welcome back for yet another expert live session. In today's live session, we'll be talking more about large language models in production. And we have Jayesh Sharma, who is a platform engineer and an MLOps engineer at ZenML. He's been working with a large language model ever since LangChain came out, and he's been experimenting with LangChain Llama Index. And he has built few of the Slack bot that helps us with how you can utilize large language models to a very extent. But when we talk about large language models, the most of the common criteria will be question and answering, code generation, code debugging. But there are also a few challenges that we face while we are working with large language model, and this is regarding computation, training, deployment when it comes to production. So we have Jayesh who will explain you in detail on how you can run a large language model in a production. So without further ado, let me welcome Jayesh and we'll start with this session.
Thanks so much, Tarun, for the warm welcome. I'm really happy to be here to talk about LLMs in production. And before I start with the presentation, I'll be just introducing the concept at large. So what we'll be talking about is how LLMs are being utilized in different industries and what challenges they pose specifically when it comes to utilize them in production environments. So let's go to the screen and then I can share my presentation. I want this to be like more of a dialogue and not just a talk. So if there are any questions that come up within this period, just let me know and I'll be happy to take them up. Or if there are any other thoughts that you have in your mind when you look at these slides or any questions, also let me know. And we'll keep this like a two-way dialogue. And towards the end, I'll walk you through some code that encapsulates all of that we have learned in this presentation. So that's how it should go. I'll quickly move into the presentation mode, and then we can
Okay.
start with
The
the talk.
screen is visible, Jayesh. So you can
Okay,
go
perfect.
ahead. Yeah.
Okay, perfect. So as I said, I'm Jayesh Sharma, so I'll be also introducing myself. I work as a platform engineer at this startup called ZenML. ZenML is an MLOps-based startup, and we help companies and data scientists to make their or build their machine learning models in a way that they're production ready from day zero. So we help them design their pipelines, design their solutions in a way that allow them to run on any infrastructure, any kind of using any kind of tools right from the first iteration. So today we'll be talking about production challenges when it comes to LLM models. We'll be talking about what pipelines are. Like when I talk about pipelines, what do I mean? And how to build pipelines with ZenML. And then I'm talking about questions. And on the right, you can see an image which kind of sums it up. So people see the revenue that OpenAI is making and all of the advantages and all of the gains that the LLMs have brought to OpenAI. But what people sometimes miss is the entire pipeline that goes in the background, which is powering these models that use OpenAI's model. So basically, if you go into ChatGPT or if you go into any other products that OpenAI has, those are powered essentially by huge pipelines in the backend, which do all sorts of things like updating the models or making sure there are validations which are running on the outputs that come out, and all those things in the backend which are not so much visible. And so, what we will do today is try to gain an insight into what these processes look like, what are the challenges that these might be, like these problems, like what are the problems that these pipelines would essentially solve, and then why it is essential in order to have a successful product on the front end. All right, so to drive home the point, what I'll be doing is I'll be taking an example of an agent. So this is the example that we will consider going forward, and all of the potential problems and the solutions will be discussed in the context of this example. So the example that I'm taking is a simple Q&A agent. So what I mean by a Q&A agent is, for those unfamiliar with what agents are just like an encapsulation, or maybe you can think of them as a wrapper around an LLM model. And what agents can do is they can essentially perform different tasks. And how that works is that the agent has access to some tools, and tools are essentially just different functions. They can be different Python functions or some other ways. And the LLMs can then decide what tools to use based on what queries the user posts. That is what an agent is. So what I'll do is I'll take an example of an agent which can answer questions based on certain tools or certain different specific domains. So that is the example that we're going to take. And what this agent will do, some of the key features would be these. So the agent should be able to understand human language. It should be backed by large amounts of data. It can construct sensible answers from whatever chunks of data it gets for a specific question, and should be powered by an LLM. And like most of these are already satisfied if you imagine agent as a wrapper around a model. Right? So if I imagine like a chat GPT, sorry, a chat OpenAI API, which is powering my agent, and then this agent has access to, let's say, a tool which has knowledge, has a vector database of all the data related to ZenML or any other company, then this agent is essentially empowered to answer questions by looking into this vector database and then figuring out the answers as well, right? So that is the use case that you should have in mind. Now, to further make you understand what the idea of this agent is, let's look at this diagram here. So this diagram here will be trying to make you understand what the flow usually looks like. And I think many of you might have already seen this if you are familiar with terms like retrieval augmented generation. So let's go through this diagram once. So what happens, what do I mean by an agent which can answer questions based on your data, right? So how does the workflow actually look like? So this is like one of the most common ways in which Q&A bots are being built right now. And you can see there are many different components. So the component which is the most essential is this LLM, which is any model you can use. It can be a Hugging Face model, it can be chat GPT, sorry, it can be a GPT model or some other model, right? And then there's a question, there's a vector store. So essentially what happens right now is if I want my LLM to be able to answer questions specific to my data, then this LLM needs to be fed some context, which is the relevant context. For example, if I ask something about ZenML, then I may need to also like feed some context which is relevant to the question that is being asked, right? For example, if I, let's say, ask a question about football, and if I ask like who is the player with the most goals this season, then I also need to maybe send some football data as a context to the LLM, and then it can basically read through the context and then construct a sensible answer based on the context and the question provided. That is the idea, right? And how that is achieved is through this diagram. So when you ask a question, what happens is you already should have a vector store which has all the relevant data. So in the case of the football scenario, you can imagine that this vector store has all the data related to the season, like rankings, statistics, and all those things, right? And when the question is asked, what happens is we perform a similarity search and we bring out some chunks of data which are the most relevant. For example, let's say this might have data about different countries, different seasons, or even different players. When I ask a question about a specific player, I might not need the extra data which is there. I might only need the relevant chunks. So this part here, based on similarity searching, it will figure out what the relevant chunks are and then feed that as a context to the LLM along with the original question. So now it becomes simple for the LLM. The LLM has the context, it has the question. All it needs to do is read the context, figure out what the question is, and then construct an answer for that. That is how it does it, right? So that sounds simple. All of that is how bots are being built right now currently. So that is called a retrieval augmented generation. So using retrieval from a vector store to augment generation of an answer. That is the idea. So far, are there any questions like if around this flow and how things work? If not,
As of now, we don't have any
then
question. We
I
can
have to.
continue.
Yeah, sorry. I have a question that might come up. Like, would this scenario work in production? So, like, so far we've been talking about how we can design these things, and there are many ways to do it. You can use LangChain as a way to accomplish this. You can have different abstractions, different models that can be used to direct this. Or you can also write your own stuff as well. So all of that is okay, but such a setup, is it possible to run this in production? And by production, I mean, can I deploy it in some endpoint and expect that this works for the customers that want to access it, right? So there are a few different questions that I might also encourage you to think about. So what happens when a new version of the data back in the LLM becomes available? So let's say I trained or I created the vector store about a particular season of the football scenario, and then I ask a question about that and it works perfectly. And what happens if, let's say, the same deployed bot is being used few months down the line when the new season becomes active? So how does this bot become aware of newer data which is coming in? So if you just create something like this, then it's not possible, right? You would have to manually go in, change the vector store, update the data which is in there, and then maybe perform any other changes like, I don't know, maybe hyperparameter changes, or maybe temperature controls, other things that need to happen on the model side. So all of that needs to be done every time data changes, right? And in the case of football, this might be in a few months' time, but in many other cases, it could be every day or every hour. So all of those things are unrealistic if you just build a simple model like this one, if you just build it using LangChain, you won't have the necessary pipelines to automate the process of keeping it up to date. And that's just one use case, right? That's just one use case that I'm asking a question about, like what happens when data comes in. There can be many other questions that are related to production that might come in, which you might not be able to solve or answer using just LangChain or any other solution that you build rudimentarily. So there is some need for automation. There is a need for a backing pipeline or something like that, which can make this system production ready and more robust. So let's talk about those challenges. So one of those questions which I already talked to you about was what happens when new data comes in. But there are many other challenges in production, right? So what are those? So there can be multiple sources of data. Data can come from documentation. It can come from messages on Slack. It can come from, let's say, Reddit or some any other places that your product might be exposed to. So if we come back to the idea of building, let's say, an agent that can answer questions based on a product, say ZenML, then you need to have many sources of data where the agent learns stuff from. Right? It can learn stuff from website of ZenML. It can learn stuff from documentation of ZenML and many other places as well. So you need to figure out a way in which you can club all of these different sources together into your pipeline. The second thing is data is constantly changing. As I said, it can change within a day, it can change within a month, or within a second as well. So all of that needs to be accommodated. So you need to have some kind of a pipeline that is receptive to changes on the data which is being made. And therefore, there's a need for automation, collection, and creating vectors out of this data. So if something changes, you can store this new version of, let's say, a vector whenever you want to do, right? So all of those things are also a requirement that comes in when you think about data in that way, right? So all of that aside, you also have stuff like tracking code changes. For example, if I think of building an agent of building a LangChain application, there are many code changes that happen, right? If I define a LangChain agent, I can do it using many steps. I can create multiple types or multiple flavors of agents based on LangChain. I can also design my own agent. Maybe I can change a prompt sometimes. Let's say if my agent right now has a prompt which uh, molds its personality in some way, but in the future I want to make it more tamed or be less responsive to fringe questions. So all of that are changes in the code level that you make. Those are not related to data at all. Those are about the code that you're writing, whether it be LangChain or any other framework. So all of those changes should also be tried, because let's say I want to move back to a version where my agent was more free in terms of what it answered. So all of those things will only be enabled if I can track all the changes that I make to the code in which I do. So you can imagine, let's say if you are building anything right now, and I'm not sure how many of you have worked with LangChain before, because in settings like these, I can't really see the audience, which is a bit of a bummer. But usually when I do this offline, I ask people about their experiences using LangChain and how the stuff goes. So if you've used LangChain, you can understand there are like many different ways or many different experimentation that happen when you're going through the process of it. And you may realize at some point, okay, maybe that is the one which was the best prompt which worked. Right? So I need to go back to that one. And if you're not tracking it, it's really hard to switch between these versions and go back between all of the different iterations that you have done so far. So therefore there's a need to track code changes to the index creation logic. And similarly, there's also a need to version the vector stores and the agents that you've created, right? So if you have, let's say, new data which comes in, if you have some other changes that happen, and you create a new vector store out of that, you also need to version the previous ones as well. For example, if I want this model to not answer questions about a specific ZenML version, I can tell them, okay, don't answer questions about this version. I can take the vector store out for the specific version and then go back to the previous one. So all of these things are only enabled if you version them in the first place, right? If you don't version your vector stores, you don't version your code changes, all of this switching back and forth is not viable. And if you think about it, in production, it's only natural to have the ability to roll back to a previous release or into like selectively control what people see or what people don't see. So all of these are challenges that you don't see when you're just developing a LangChain application locally. All of these will only become visible when you actually deploy it to production, right? And then apart from that, there are also concerns about leakage of data through proprietary LLMs and all of those things which also come into picture. But those can be solved through multiple different ways. You can use, let's say, Azure OpenAI. You can use some other privately hosted LLM as well. So all of those so far cover the challenges that we see in production, right? So a need for tracking, a need for automation, need for versioning, all of those things are something that can't be achieved through a simple model like this, right? So what we do is then we have to use some kind of frameworks that allow you to design pipelines in a way or design your code in a way that addresses these challenges, right? So ZenML is a open source framework, and ZenML allows you to build pipelines in a way that they're production ready from day zero. What I mean by that is, imagine how you currently write code. For example, if you are thinking of a LangChain application, I can imagine you may have a notebook where you experiment with these things. You have a function which creates a LangChain chain, and then it uses some kind of custom prompts. It uses some LLM model, and then you run some queries against that chain, right? And all of that code is present in some kind of a notebook. It is probably not organized because uh, this is sufficient enough. Like you can just run whatever you want within this specific block or a few blocks of code. But what we encourage people to do is right from the get go to think of their solutions in the form of pipelines. And pipelines have these different steps. So what we need to do is we need to think of our problem, our solution, as a form of different steps which are clubbed together and which work together as a whole unit. Right. So what ZenML does is it allows you to just use native Python to design pipelines in such a way. So you can just use, let's say, a step decorator or some kind of decorator on top of a Python function, and using that you can define pipelines and steps. That is the idea. And we will look at the code when we want to understand it better. But so far, you can just understand that ZenML allows you to design pipelines in such a way that all of these is production ready. And tracking and versioning of artifacts, caching of steps, all of these things are enabled by default. So when you create a pipeline in ZenML, when you define different steps in ZenML, and when you run this pipeline, caching is enabled by default. You can also disable it, of course. But what happens is ZenML tracks what each step outputs. It stores those outputs in some kind of an artifact store, versions them as well. So you can choose what pipeline run you want to go back to, what pipeline runs, what step, what output you have to look into. So all of those things are versioned and tried automatically, and that is stored in your artifact store, which you configure separately. And then there are logs and visualization of outputs with the dashboard, and then many more different capabilities that get unlocked if you start building pipelines with ZenML. And that's just the tip of the iceberg. So that is the idea. And now what happens is, let me talk more about the idea of the pipeline. Like I've been talking about pipelines so much, but why are they really necessary? What is the advantage of having to build a pipeline and not just use a notebook or just write different blocks there? So having a pipeline in a way enables you to structure your problem in different steps. And that has many benefits. It allows you to automate the tasks, because there might be many manual tasks that you perform in the course of building your model, or in the course of, let's say, building your agent or LM chains that you do manually. But if you club it together in a pipeline as a step or as multiple steps in a pipeline, what that enables you to do is you can also click run once, and then it basically goes through all the steps and then automates everything together. So you don't have to do some manual steps, some automated steps. So that can be all clubbed together in a single unit. You can then swap implementations of different, like let's say, for example, in this example, if I want to have a different trainer, if I want to have a different importer, I can just swap the implementation of the importer with a different function, and then the pipeline code still remains intact because the pipeline definition is still the same. I can just change definitions of a single function there. It also has many other benefits, like it allows you better debugging abilities. It can tell you what step failed, because you can look at, okay, this step failed, which means the other steps are working properly, but this is the step which I need to debug. You can allocate different resources per step. Let's say trainer requires more resources than importer, maybe then you can maybe run the trainer on a GPU compute or importer on a CPU compute. So all of those things are allowed. Like different scalings can happen if you structure your pipelines as a combination of different steps instead of having like a single block of code. That is what it does. And there's also, of course, caching. So if you run your pipeline multiple times and there are multiple steps in there, and let's say if only the validator step or the deployer step has changed, all the previous steps can be cached. So all of those steps won't be run again by the pipeline, and only the last step will be run. So that saves upon compute time, that saves upon resources. So all of that comes into the picture as well, right? So that is the idea, and that is why I'm stressing on the idea of having a pipeline to structure your machine learning applications. And how you build pipelines, that's also really simple. That is simple as just adding a simple decorator. For example, in this case, you can see there's a function called fine tune llama. And what I'm doing here is I'm just adding a step decorator on top of the function. And that's the only difference you need to have. So to make a function a step, all you need to do is just add a decorator on top. And that will make ZenML know that, okay, this function is a step somewhere. So that is the idea. And then you write pipelines with a similar way. You can also define a function which clubs together different functions. and then you can add pipeline decorator on top of that function, which can tell them, look, this is a pipeline and this has these many steps and how they are linked between each other. So all of that is how you write pipelines in Python native. So you don't have to learn about new languages or you have to write YAML files, anything like that. You can just do it right in the Python code itself by just using a decorator. So this is how you define pipelines. Then what happens is the next step is you create stacks. So what I mean by stacks is what runs your code. So you can either run it locally, you can run it on the cloud, on GCP, AWS, Azure, wherever you want, or Kubernetes clusters, on a local cluster. So all of those can be set through something called a stack. I don't want to talk about the stack here so much, but this is something you can explore. So essentially with ZenML, the code and the stacks are different. So you can keep your code intact and keep changing the stack to be able to run the same pipeline anywhere you want, basically. That is the idea. So all of that is how it works. ZenML handles building of images, pushing of images, and all those things in the backend. So you don't have to worry about it. You just write the pipeline, and that should be sufficient enough, right? So back to the Q&A agent. So far, are there any questions or any doubts or any feedback that you might have? If not, I'll just
Yeah,
proceed.
we have two questions. I'll just add that to the screen. The first one is any
Okay.
strategies to solve the issue of large data processing in production?
Large data processing in production. What do you mean by that? Is it maybe let me assume something and then I'll answer. If it doesn't answer it, you can give a follow up later. So I assume you mean, let's say, if it's about what happens when people upload their PDFs, like are you talking about in the LLM scenario that people might
Yeah,
bring their own data in and then you have to somehow read the data and answer questions based on that? Because if that is the case, then in most scenarios, what I imagine it would be strategies. I'm not so sure if I have a coherent one at this point, but let me think about it. If you Yeah, those things I'm probably not super sure because I don't have a concrete strategy I can give it to you. But like all you can do is you can have a pipeline. So how I would do it ideally would be this. I would have if I have a product which can accept data, huge amounts of data from the user, and then I have a bot which can answer questions based on that. What I would do in the backend is I would create a pipeline. Like I'll show you the pipeline right now in a few minutes. So I'll have this pipeline in the backend. What this pipeline will do is it will take the URL or whatever data, the way in which data is being fed. It will take that, it will import that data. It will run this pipeline in the backend on whatever compute I have. Maybe it be Vertex AI or any other serverless compute. And then it will populate a vector database in the backend. And then I'll plug this database with my agent here. But I am not sure if I can be more detailed than that. You can use, like, when you run this pipeline, you can use many other different things. So for example, if you have large amounts of data, you can maybe run parallel jobs which do it. You can use Spark, you can use many other parallel compute things, but all of that will be part of the pipeline. So how you run this pipeline? So you define a pipeline once, but as I said, you can have a stack here, and this stack is what decides how fast your stuff runs. For example, if you have large amounts of data, you might want to have a stack which can support parallel computations, right? And that will make sure that your pipeline runs super fast and it populates the database super fast. So all of that depends on what stack you choose. So maybe if you're using Kubeflow, maybe if you're using Apache Spark or any other step operators which can support parallel operations, that will be the fastest way to do it. So that is like recommendation off the top of my head. What's the next
We
question?
have one more question. Like,
Mm-hmm.
does pipelines mean writing code using functions?
Yes, exactly. So the basic idea is this. So when I show you the code, it'll be much more clearer. But the idea is that you have to imagine your use case in the form of multiple functions. So let's say if I talk about this use case, this is a very simple pre-GPT era pipeline, which, like, if you are familiar with training your own models, you can imagine a pipeline like this. So essentially, there's an importer step which imports the data, there's an analyzer step, there's a trainer step which trains the data, there's a validator, there's deploy. So all of these would generally be used in a single notebook. So you can have a large notebook which does all of these in different blocks, right? All we are wanting to do here is to make sure that these blocks are separated into different logical concerns, and each of these are different functions in itself. So I'll club together all the lines of code that import the data or that maybe process data into a single function. I'll call this define importer, and I'll add step decorator on top, like add step define importer. So that becomes a single step. So all I want to do is take my notebook and then separate them into different logical functions. And when these functions are ready, I'll just add a step decorator on top. And that would mean that these are now different steps. And then I can define a pipeline function which links these steps in very logical ways. So maybe the output of the first step goes into the second one, the second output goes into the third step. All of that can be defined in the pipeline function. And I'll show you that when we get to the code. But the idea is exactly the same. You have to define it in terms of pipeline, in terms of different functions, basically.
Okay, we
Are there
have two
any?
more questions, but we'll take that after you complete the slides and before we go to the code.
Okay, perfect. Okay, perfect. So far, what I've talked about is this. I have talked about the need, about the different challenges in production. Like there are many different challenges, and we also talked about how to address these challenges. So the idea would be that we define a pipeline first, because that allows us to run our code in production in many different ways. Because if you write it with ZenML, you can also run it on, let's say, Vertex AI. As somebody asked about large amounts of data, you can choose a different stack which suits your need without having to change your code. So all of that is enabled if you write your code in the form of pipelines using a framework like ZenML. So that is the idea. And now let's talk about the Q&A agent again. So far we have covered a lot of ground. We have talked about pipelines. We've talked about these production challenges. Now we'll come back to the example at hand. We were talking about an agent that can answer questions based on some documentation or some other data, right? That was the idea that we had initially. So, and I also showed you the diagram, which is usually how people do this bot things right now. So they have a vector store, they have LLM, they have relevant chunk similarity searching. All of that is how things work. So if we think of that idea right now, and if we think of all the production challenges that we saw, how do we merge these two things together? So let's say if I look at this diagram again, how do I make this production ready? Like we already answered the question that this is not production ready, of course, because if new data comes in, there's no way it will work, right? So how do you transition this architecture diagram into something that is production ready? So I want you to keep this image in mind. And now let's look at the points here. So the first step that I might think of is the vector store that is backing the LLM that needs to be updated with new information as it comes, right? Because let's say it needs to be receptive to any new information that's coming in. So if a new version of ZenML comes out tomorrow, this vector store needs to be updated automatically. Then there should not be any manual process. If a new Slack message comes in and there's a lot of conversation on our Slack which is relevant to the bot, like there are like, a lot of times people share information on Slack, which is super important. So all of that should also be fed into the bot. So there are many other things which happen. So the vector store, which is the brain behind, which is the power of all of that documents, needs to be updated regularly with the new information when it comes in. There needs to be an ability to switch and deploy different versions of the bot, which is also true, right? Because if I let's say deploy a new version, if a new version comes out, I want people to switch to that new version and not use the old version anymore. So I need to be able to switch between these different versions. I need to be able to track changes to the code and the output. So all of these are the requirements that if I fulfill on the original architecture diagram, I'll be able to have a production ready system, right? That is the idea. So how do we do each of these things is something that we'll discuss right when we go into the code. So this is the pipeline, which I think might solve the problem, right? So what we do here is this. We have a pipeline which automatically updates the index based on some input. So this pipeline, I'll just walk you through the different steps here. So the first step is a URL scraper. Now this could be any URL. This could be a documentation URL, which is holding documentation for different versions of ZenML. This could be a website URL. This could be Slack messages. So all of these are different URLs. So URL scraper looks at different URLs, figures out different parts of the URL. For example, if you just give a website root URL, it will try to figure out all the different parts the URL has. The second is a web URL loader, which will load all of the documents based on these specific URLs. So if you have a whole bunch of URLs, this step is going to load those in documents. And the third step is generating the index. So the third step is what will generate an index. By index, I mean a vector store essentially. It will generate the vector store based out of all of these URLs. And the fourth step is what will create an agent out of this. So if I have a pipeline like this, then all I would need to do is set up some trigger, set up some GitHub action. I can do it in many different ways, right? So set up some trigger that whenever a new version comes in or whenever this thing happens, some event happens, this pipeline gets triggered, right? And using ZenML's caching, if there are no changes at all that happen, the pipeline won't be run at all, right? It will just use the cached version. But let's say if a URL changes or if new data comes in, then this pipeline will be run again, and all of these steps will be followed automatically. So you don't really have to do any of the steps manually. You can just set this up automatically through a trigger. That is the idea. This will solve some of the problems here. This will allow you to automatically trigger pipelines when new version comes in and set up different vector stores. And since it's a ZenML pipeline, it automatically tracks the outputs of each of the different pipeline runs. So, if, for example, if I want to go back to some version, I can just choose what pipeline run do I want to go back to. I can list the pipeline runs that I have on the dashboard, and then I can choose a single pipeline which I want to access, basically, and then I can create an agent based on that. That is the idea. So all of those things are empowered, are allowed if you use such a pipeline. So with that said, I'll jump to the code, but before that, let me answer all the questions that are pending, and then we'll jump to the code.
All right. So once, is there any reasons why you choose ZenML? Can I use Apache Airflow instead?
Yeah, of course, you can use Apache. The thing is, like, Apache Airflow is an orchestrator which ZenML also uses. So ZenML is not an orchestrator in itself. ZenML is just a framework. It's an open source framework which pulls different tools together. So Apache Airflow is an orchestrator. It allows you to define your pipelines and then run them on, let's say, a Kubernetes cluster, wherever your Apache Airflow is deployed, right? That is the idea. What you can do is you can define your pipelines in ZenML and then also have them run on Airflow. So Airflow can be an orchestrator. So just to drive that point home, what I'll do is I'll show you the documentation a bit. This will help you understand better. So if you look into the component guide on the ZenML documentation, this will show you the list of orchestrators that we have here. And one of the orchestrators is an Airflow orchestrator, right? So this is an Airflow orchestrator. So what happens, what I mean by that is this: if you use Airflow, it will work, of course. But let's say if tomorrow I want to move to, let's say, using a Vertex CI pipeline, or if I want to use, let's say, AWS SageMaker or some other thing, then the onus is on you to translate the code from Airflow code to, let's say, to work on SageMaker or to work on Vertex CI, right? That is something that you have to do yourself. But if you instead write pipelines in ZenML, you can choose between different orchestrators you want. For example, today I can run on Airflow because I have Airflow deployed. But tomorrow, if I get access to a more powerful SageMaker cluster, or let's say a Vertex cluster or some other kind of stack palette VM cluster, so I can easily switch just the stack without having to change any of the code. And the ZenML is then responsible for translating all of your pipeline code into any of the different orchestrators that you use. That is the flexibility that ZenML offers. And it's not just orchestrators. You can look at different artifact stores. For example, if I want to be able to store my artifacts today in an S3 bucket, but tomorrow I want them to be in Azure bucket, or tomorrow I want to be in a GCP bucket, I can switch between different artifact stores. And there are a whole bunch of different stack components that ZenML has integrations with. So you can choose different model deployer. How do I deploy a model? Do I do it through Hugging Face? Do I do it through AWS SageMaker, through Vertex, or any other different Selden? Many other tools are there. Tomorrow there might be a new tool which comes out. So all of those are allowed just by using a single ZenML pipeline. So you don't really have to change any of the code. You can switch between these many tools. So of course you can write the same in Airflow as well, if that's something you're pretty comfortable in. But I would recommend that you write the code in pipeline in ZenML because it doesn't require you to have special syntax. You can just use your existing Python code and slap the decorators on top, and then choose an Airflow orchestrator as your preferred means of deploying this product. That's the idea.
Okay. So we have one more question.
Mhm.
How would be the branching strategies for MLOps project with four environments? LLMOps. So
How would be the branching strategy
for LLMOps project with four environments,
with foreign environments? You mean?
it's given four environments.
Okay, with four environments, I am not sure what the four environments are, to be honest. Like, if there's some other follow up, like maybe we'll come back to the question. Maybe you can write a follow up defining what the four environments are, because I am somewhat lost.
Jay, if you are still around, please let us know what is this four environments.
Okay,
Okay, we'll
so
proceed with the code demo. I'll
perfect.
just add the GitHub URL.
Mm-hmm.
Okay, so there is a follow-up question.
Yeah,
So
yeah,
it's
go ahead.
like dev, QA, non-pod, and prod, four
Oh, okay,
environments.
okay, okay, okay. So what you want is strategies for MLOps. I So usually how it goes is the same as software development. So you don't really have to think about it in different terms than um, what software development traditionally is. So the main goal with MLOps that we try to address with ZenML and with tools like these is that we want it to be as familiar to a software developer, or like it to be as similar to the flow that we have as software development. For example, people should be enabled to push to some GitHub repo, trigger pipelines, have them run, and then look at the outputs in different dashboards, observability. So all of those things are still the same concepts with ML flow, and then that extends to how we manage environments as well. So what I would do personally would be this: I would have, let's say, if I want to have a staging environment, Let's say, let me talk about staging and prod initially only. So if I want to have a staging and a prod environment, what I would do is I would first deploy, like I will have two different deployers, maybe a single deployer, but two different clusters. And the first cluster is a staging cluster, the second cluster is the prod cluster. When I define my pipeline, I can have the last step check for a variable. So if I go into, let's say, uh, this example, if I go into this pipeline that I show you, if the last step is a deployer step, what you can do is you can pass in a variable, which is, let's say, environment. It can be staging or prod. You can check in this deployer implementation, or you can check in the pipeline definition as well, that if this environment variable is set to, let's say, when I define the pipeline. So if I show you the code where pipeline is defined, so if I show this part, 1 second. So this is how you define a pipeline. You define a Python function and then you link different steps together. So what I can do is I can pass in a variable to this function which says environment, and then I can check here if environment is, let's say, staging, then this agent creator is replaced by some other function. So agent creator underscore staging is my agent creator staging function, and that function deploys the agent or creates the agent based on the staging settings or staging variables. And if the environment variable is production, I can use a different function here. So while defining the pipeline, you can choose what environment variable comes in, and based on that, you can try to use a different function definition altogether. Right? That is the idea. So that will become clear if I go through this notebook quickly with you. And the idea is simple. If you have a pipeline, you can easily swap different steps based on different parameters that you set. Right? That is the idea, which makes it really modular, really flexible, and which provides you to switch between different environments really quickly. So I hope
Okay.
that answers it. We'll get
Yeah,
back to it as
that's all the question we have as of now.
well.
Once again, I'm just adding the notebook URL in the chat. You can just copy paste it, and if you want to run along, then it will be better. And if in case you have any question, we'll be taking it after the code demo. Yeah, go ahead.
Okay. Yeah. So this notebook can be run in Collab if you wanted to. But so far, I have just like there are some outputs that are already part of it for demonstration purposes, so that you can look at this thing and imagine. Because usually, if I run this pipeline, this will take a lot of time because it is built on top of ZenML. So we already have this deployed in our Slack. So I'll show you the link to the Slack that we have, and there's already a bot which answers questions based on ZenML's documentation. So it's already in process, and this notebook is exactly the same as the one which we use to train that production bot. And therefore, it takes a lot of time to look in different URLs, scrape them, load them, and do that stuff. But thankfully, all of that is visible as outputs here, so that will be easier for you to understand how this works. So I'll quickly go through it, and then this will help you understand what the flow is usually like. So okay, so sorry, my bad. Yeah, so I'll jump straight into the concept of a stack first. So we have talked about like why pipelines are important. All of that is already covered here. So this is what the case for NML pipeline discusses. So you can just read through it afterwards, but I'll not be stressing on it again. And this is part of ZenML setup, but these are things you can also read up on the documentation, not really essential right now. What I want to talk to you about is a stack. So a stack, as I already mentioned, is something that allows you to define where a pipeline is run. So there are two parts to it. There is a pipeline and there's a stack. And ZenML tries to combine these two together. So if you define a pipeline once in your code, in your Python code, you don't have to worry about changing this pipeline code if you want to run it somewhere else. So that is the responsibility of a stack. So if you can have many different stacks, you can have a local stack, you can have, let's say, a remote stack, or any other different stack that you want to name, and those stacks will have different components. So we can have an orchestrator, as I showed you, the all the components here, all of these are form part of your stack. So you can create a new stack which has a different orchestrator, maybe not an Airflow, maybe a Tecton orchestrator, right? So you can define a stack which has many different components, which can be of multiple different flavors. So an orchestrator can be a local orchestrator, a Kubernetes orchestrator, Airflow orchestrator. All of those things are there. So this is what a stack means. So ZenML allows you this flexibility to switch between different stacks. That is the idea. So right now, if you just start with ZenML, if you just run this notebook as a fresh user, you'll have the local stack. And that stack looks like this. It has a default orchestrator and it has a default artifact store. And what this means is that the orchestrator being default is a local machine. So when you run this pipeline is going to run on your local machine. It won't submit your job to an Airflow cluster. It won't submit your job to a Vertex cluster, but this is going to run on your local machine because that's the only thing you have configured right now. And the artifact store is also local, which means that all the different paths, so no matter how many times you run this pipeline, the different runs, all of those, the outputs of the different steps will be stored at some path in your local machine. And those will be versioned. So if a run is a new run, then it will be stored at some different path than the previous one. So you can also look at all of these different paths to see what the outputs of each of your steps were. So when you first run this notebook, you'll see that you have a local default stack, and this is the same as the slide which I showed you earlier. This is the pattern that we're looking at, and all of these are different steps, and essentially they read and write from the ZenML artifact store. And this can be your GCP artifact store, S3 bucket, Azure bucket. So all of these are where your artifacts are tracked. It can also be local thread. So these steps just read and write from this specific artifact store that you have. That is the idea. So if I already mentioned about the different steps and what these steps do, but let's quickly take a look at how these steps are defined. So I mentioned to you that there is a URL scraper, there's a web URL loader, there's an index generator, but how do you define these steps? As somebody already pointed out, it's nothing but just a Python function. So if you don't look at any of the other code here, if you just look at these lines here, this is something you would already use in your, let's say, a notebook or some other place where you write your code. All you have to do is just define this as a function now. So this is a define URL scraper, and then I've added a step decorator on top, which makes this a ZenML step, right? And this is imported from ZenML. So I defined a URL scraper. It has some code which does URL scraping. You don't really have to worry about all of that code because it's just simple. It doesn't have any LLMs involved, doesn't have any GenAI. It's just simple Python code which scrapes different files. If you want to take a look at all of this code, you can also go in here. I can show it to you. So if you go into the root project, if you go into source, there is this steps folder, and all of the steps are listed here. And there's also URL scraping utils, which has the different get all pages and all their different functions. So if you want to really dive deep into how these steps are built, you can also look into these. But the notebook just has the most relevant chunks here. So that is for demonstration purposes. And you can see we import other things from different steps folder, right? So you can also go there and see if you want. And similarly, there's a web URL loader. It just uses unstructured URL loader from LangChain, and then loads different URLs in different documents. The step which might be of interest is the index generator. So what index generator does is it creates a vector store based on all the documents that you have already fetched. So the first two steps were the steps which created the documents from different URLs, and the index generator is where you actually create a vector store based on those documents. And you can see here we're using a files vector store, but you can also use some other one. You can use a Chroma, you can use a V8 or any of the new ones that LangChain supports. But in this example, we're just using the one by Facebook. So what we do here is just we define an embedding, we split the text, we create a vector store based on the functions that this provides. So all of this code is just the same as you would use if you were to use LangChain. So there's nothing ZenML specific here. So it is just the same as before. You just club that together in a function and add a step decorator on top. That is the idea. And once the index generator is ready, you can take a look at the agent creator. So this is the step which creates the agent based on the vector store. So if you're not familiar with agent, don't worry about it. It's just a new concept with LangChain. What happens is you define an agent which is backed by an LLM model and which also has access to a set of different tools. And by tools, I mean one of the tools can be this vector store, right? So it just tries to use one of the different tools based on the question that is being asked to this specific agent, right? So that is the idea. So we define an agent again using LangChain. So all of that can be used. We essentially use LangChain in the code, but we superpower this application. We superpower this entire use case by using ZenML because that allows us to define pipelines. It allows us to define different ways in which this is deployed, where it is deployed, to track changes. All of that happens here. So I need you to understand the basic idea. So ZenML or any other tool doesn't seek to replace Airflow, doesn't seek to replace LangChain because that's stuff which is best controlled or best done by LangChain here. But what you do is you just try to supercharge or superpower your LangChain applications in a way that they're production ready. That is the idea. So you use exactly the same kind of code that you use normally with LangChain. You define tools using different tools that LangChain offers. You define an agent based on a conversational chat agent that LangChain offers. And then you define these settings here. But in the end, you just return agent executed. You return the object. So when any function returns something, that is the clue for ZenML to be able to track these objects. So all of the different functions that you see, they return some of the other things. So when you return something, then ZenML is automatically tracking those and making them available for the future steps. So as you can see that this index generator returns a vector store, and you can see the next one takes a vector store as an input to this function. So ZenML now makes sure that the vector store is available to the next step from the previous step. So where it is stored, how it is fetched, all of that storing and fetching happens with ZenML. So you don't really have to worry about where this is being stored. And that is created by your artifact store, right? That is the idea. So you define all of these different functions, and then you create a pipeline. And we already looked at this code before, thanks to a question. So what this code does is it just defines different steps and how they are linked to each other. And the linking is done through data. So I tell you that, okay, URLs is the output of this first step. And this step itself is the same as the one which you defined above. So this is the name of the function that you defined above. So agent creator is the same name as a function. So if I want to use a different function here based on my environment, all I have to do is I have to define a new function. Let's say define agent creator staging, put the code there based on this staging settings that I have, and then just use that instead of this agent creator code, agent creator function here. And that will create a new pipeline version which has this specific agent, basically. That is the idea. So you define a pipeline here, you link these steps together. So URLs is the output of the first step. It is fed to this one. Then the output of this step is fed to this one. So all of that is linked through data. And then ZenML will create a graph based on this data. So you don't really have to worry about how these are structured. You just need to worry about what data goes into which function. And then ZenML will automatically make sure that they can run in topographical way. So it sorts it in a way and then figures out what the order of execution should be. So that is the idea, and then you can run this pipeline here. So if you have an OpenAI key, you can just run this model straight through. But if you want to edit, if you want to use some other model like a Hugging Face model or free model, you can also do that. Because if you go into these steps here, if you go into the agent creator step, you can see there is a place where we define the LLM. That is where we define an LLM. So you can change the model name to some other model, like say a FLAN model from Hugging Face, Google's FLAN model. So all of that is flexible as well. So you don't really have to worry about being locked into any of these things. So it's pretty flexible to switch between different things. And those are just LangChain qualities as well. You can choose between different LLM applications that you have. So once you define a pipeline using this, once you define a pipeline using different steps, you can then run this pipeline. And all that means is you just call this pipeline function. So this is the function that we defined earlier. And what you can do is you can just call this function with different variables as input here. That is the idea. And then this would set off something like this. You can see there's some version of the pipeline that is being run. This is the 14th version because I ran this multiple times. So every time you make some changes to the code of a pipeline, it registers a new version automatically. And this allows you to switch between different versions as you want. So you can easily go between different. I'll show you where the fetching happens. But usually when you run a pipeline, this is what it looks like. It starts a new run. It uses whatever stack you have set as an active stack. And then this is how it works. So you can see, since caching was enabled already, this is an example of that caching being in action. So you can see the step URL scraper. There's a cache version that was used for web URL loader and not the actual version. So it used some cache steps, but then it used an actual step. So the step index generator was actually what got executed and not the first two steps, because those were already cached from a previous run. And then this is how it works. It finishes in whatever seconds it wants. And once it is done, what you can do is you can try to load different versions of the agent. Because remember, we have the final step, which is the agent creator, and it returns an agent as an output. So what I can do is I can now call ZenML. I can tell them, okay, I need this specific pipeline version. I need the latest run from this pipeline version. And I want to get the agent object out of that, because this is the agent I want to deploy to an endpoint, right? Because I need the latest agent to be deployed to my endpoint. And how I do that is through this code. It's very simple. I can just import the client. I can do client.get pipeline, provide the name of my pipeline, whatever pipeline there is. If you don't specify a version, it just takes the latest version by default. But you can look at this example. You can also specify a specific version. So by default, this will take the version 14 because that is the latest version here. But you can also specify version 9 or version 8 or whatever different version that you were using. So this is the code which is the responsible one for deploying any specific version of your agent. So you get a pipeline model, whatever version of the model you want. Then you choose the pipeline run. Here I'm getting the latest run, which is the 0th index. I can choose any different run as well. And then I'm getting the agent creator step, which is the last step of my run. And then I load that output from that step. This is the agent. So this is the agent I load. And then in the future, what I do is I use this agent object to run queries against it. So you can see it. I ask a question, who are you? It says I'm a ZenML agent operated by ZenML. That is the idea. And then you can also ask where I can run. So all of these things, you can see it depends. It chooses what action to perform. So in this case, it doesn't use any tools. It just answers in a way. But then if you ask any specific ZenML questions, it looks into the ZenML tool, which you already set using the vector store, and then answers a question specific to ZenML, basically. That is the idea. So far what you've done is, like, this is the part which is the most crucial one. Because if you imagine a production system, you can choose what version of the agent to deploy based on what pipeline version and what run of that pipeline version you want to choose to load the agent, essentially. And this is what allows you to have multiple different versions even running parallelly together. So that depends on where you deploy your model. But ultimately, this code is what enables you to fetch different versions and keep track of all of those changes that you have made in the previous thing. So that is I think the whole idea of how this thing works. Are there any other questions that I can answer based on this?
Okay, so if you have any question, please feel free to ask. As of now, I am not able to see any question. So there
Okay,
was
perfect.
one like do it tag based, but I guess this was reply to the
Mm-hmm.
four environments.
Okay. Yeah, tag based. I think yeah, it depends on what how you want to implement it. But essentially, you can just choose different pipeline version. You can just use different environment variables to switch different pipeline definitions, and that should do the job. So there's no specific like not one solution for everything. You can choose whatever works best for you, essentially. But like this pipeline is what covers like most of the ideas around production, because we didn't really talk about langchain because that is something I assume that people would do it themselves. But this is part of the problem where people don't seldom talk about, like which deal with how to cache steps, how to run pipelines out in automated fashion, where to deploy your pipelines, how to scale them. So all of these are what this notebook tries to address. So if you have time, I'll be really happy if you would go back home and then run this in Colab or maybe locally on your machine and see if this works for you. And then you can also play around with different versions. You can change settings for different agents and see different versions of agents behaving differently when you change the version that is being loaded. But that is the idea.
Okay, so I have one question from my side.
Okay.
When you showed about tracking and using the stack, and
Hmm.
I also saw you used MLOps and different tracking that we can use using the
Yes.
stack. Now, suppose when I'm building this agent, usually when I'm working with large language model, it's obvious that I'll be writing prompt, and in order to get better result, I'll be playing around with different prompt to get the better
Yes.
result. Is it
Yes.
possible to track the prompt itself?
Exactly, it is possible because so the idea behind having a step which returns an agent is precisely to track the prompt as well. Because if you look into the code, let me show you. So an agent here, this agent, this has let me show 1 second. So I think it'll be better if I use VS Code. So if I go into the agent, so every agent that has been defined has a prompt by itself, right? So if you are familiar with how agents are built in LangChain or maybe in any other paradigm, there's always a prompt which defines how the agent behaves, right? So you can see the question which I asked the agent, it answered that this is an ML agent. So that is only done because I added a prompt that told the agent it's an ML agent, right? And all of that prompting that happens inside the prompt.py or any other way that you define it, but essentially it's part of the agent object. So if you look into the agent object here, so if I go into the agent here, so if I dive into this object, if I dive into this class, you can see there's a function called create prompt here, and this is the prompt which gets created, and this is based on whatever like variables that this being set in this specific file, right? So essentially the prompt is part of the agent object, and when I return the agent as an output of a step, so if I look into this specific step here, when I return the agent as an output of a step, ZenML automatically tracks this whole object. And by tracking the whole object, it's also tracking the prompt which comes with it. But if you want to track something specifically, you can also return that as a specific step. So as implementation of an agent creator, you can also return not just the agent, but any other variables that you want to track, essentially. And then any outputs of a step are tracked by default. So in this case, when I'm returning an agent, ZenML is tracking all of the different versions of an agent. So when I call this agent here, when I call agent.run and ask who you are, it tells us ZenML agent. But in the future, if I try to change my agent definition to include some specific other prompt which says, let's say you are an AI Planet agent, for example, and then what would happen is if I run the pipeline again, then the latest version of the pipeline will have an agent as an output, which is an AI Planet agent now, because that is the prompt which is being fed into it. So all of these changes that you want to be able to track should be made part of an output of a step, because then ZenML is able to track those changes. Essentially, that is the idea. Was that clear to you? I You're mute,
I'm
Tarun.
on unmute, sorry. Okay, so when we are running this, right, agent,
Mm-hmm.
I mean, can you scroll a bit down? Entering the agent executor chain. So this is
Yes.
part of verbose equals to true. It happens in the backend, right? So are we
Yes.
extracting this content and then separately storing it, or uh, the create agent what you showed, that particular pipeline, it takes care of that?
Yeah, so this output, this is not stored, of course. Like this is an output which is happening on the production side. So what we are doing here is when you this code which you see here, the testing the agent, that is independent of the pipeline code. What we are doing here is we are trying to fetch some specific version of an agent which is already run through some pipeline and then running some tasks against it. So now all of these things become the domain of where you deploy your agent. So if you deploy it in some place which can track these outputs, you can do that. But if you're talking about the prompt which powers the personality of the agent, that is defined when you create the agent. So if you go into the agent creator step here, this is where your agent is defined. Like how will the agent behave? What are the prompts that go into the agent? Like I can tell a prompt that let's say agent, you are ZenML agent, you are powered by this and that, and you can answer questions based on these many tools. So all of the prompts which mold the behavior of an agent, that goes into the agent creator step. And you can change the agent creator step, you can change the prompt there, and that will be tried automatically by ZenML, because since this is a step of ZenML and since this is an output of ZenML, what it will do is automatically track and version these different outputs. So if you change a prompt here and then run the pipeline again, this will create a new agent for a new version. And then you can use that specific agent version in the testing code here. That is the idea.
All right, understood. So we have one question like,
Mhm.
how to scale the pipeline? Does the logic in the code would work with Llama index?
Yeah, of course. So there are, I think, two questions. So if you want to scale the pipeline, you can do it in many different ways. So for example, I can show you an example where there is there's a stack component called a step operator. So when I talk about stack, it's just a combination of different stack components, right? And what a stack is where your pipeline is run. So by default, there's a default stack, as I already told you. So it runs locally on a machine, which won't scale well. But what you can do is you can add a step operator to your stack. And what a step operator is essentially an environment which you can define for any specific step. So let's say if I am talking about index generator, which is the most expensive step here because that runs index generation for a huge number of different URLs. So in that case, what you can do is you can ask ZenML to run a specific step on some other environment. So you can choose from Azure ML, Vertex, SageMaker, Spark, any other custom implementation that you want. Since it's open source, you can also create your own implementation, of course. But the idea is this: if you want to scale any specific step, you can also choose a step operator for that specific step. So ZenML will run your pipeline in whatever orchestrator you want. Let's say you run this thing in Airflow by default, but a specific step needs to be run on Spark because it's distributed compute. So you use that as a step operator. So that is how you scale it. But none of those things would require you to change your code in any way. So all of the pipeline code that you see here, this will still stay the same. This will still run the same. All you have to do is just add a new code block here which says ZenML stack set, and then set your own stack. Basically, you can create a stack based on your requirements. You can have a step operator inside of it. You can have a different orchestrator, whatever, and then set that stack as an active stack. And then when you run the pipeline, ZenML will run the same code on this new stack based on this thing. So that is how you scale your pipeline. So that depends on where you want to run it. That is the idea. And of course, it works with Llama Index. That's not a problem because, as I told you, so the LangChain part of this is not important. So any of the step implementation here is not irrelevant in a way, because all I'm doing here is in defining a pipeline, a structure here which has different steps, and these steps can have any implementation as you want it to. For example, the agent creator here, we don't really know what the agent creator does. It can use LangChain, it can use your own code, it can use Llama Index or whatever other index that you want. So the index generator here can also use Llama Index to create an index. So that is something which you can do. So all that would require is for you to go into the index generator function and then change the implementation in any way you want. You can just replace the LangChain code with your Llama Index code, and that will still work the same. So it doesn't really matter at all. So whatever Python code you have, it works with anything, essentially. That is the idea.
So to summarize the index generator, it is nothing but you're taking the data, then loaders, then embedding, and then storing it in a vector database. So that's the
Exactly.
process of, okay. Then I guess this is
Exactly.
similar to, you can either use LangChain or Llama index. The
Exactly.
process is
Process is the same. You're right.
okay. So we'll wait for 2 more minutes if we have any questions or not. Until then,
Mhm.
if you want to join our Discord community, here is the link. For further any more question, if you are unable to join live, then you can join the Discord community and ask your question. Yeah. You have any closing thoughts, Jayesh, on how someone from data scientist background can learn about LLMOps? Like, do
I
you need
think
any knowledge of deep learning or directly learn LangChain, Llama Index, and get into it?
yeah, I think that depends on what people want to achieve. So if let's say if you're working with an idea that you might want to first learn how models are built and maybe in the future research on these things, then it would make sense to dive into like deep learning or those concepts. But if you just want to play around with let's say how agents work or how APIs are used, in that case, it might not be essential. So in that case, LangChain is good enough. So that really depends on what you want to do. If you want to go into research, if you want to go into building models yourself in the future, then it would make sense. But I think in the future, it would be the case where you'll have smaller models which are fine tuned on different implementations. So right now, what happens here is people just use OpenAI's or any other APIs and they can just use that. But in the future, there will be fine tuning of models, which is where again the knowledge form of machine learning will come in. So it's a safe bet to make. If you still learn machine learning concepts, deep learning concepts, then it makes sense because in the future there will be a case where you have to fine tune your models, and in that case, the knowledge of machine learning will help you because you will know what hyperparameters to use, what different things to set, and how to train your models in that way. But right now, if you just want to play around with the API which are already available, don't really want to fine tune stuff, just go with LangChain, and then it will be the fastest way to build LLM applications on top of them. So yeah, it depends on what you're looking forward to achieve. I think, but both of these are really promising avenues.
So, like, there is one question. Would you please share the presentation deck?
Yeah, sure thing. Sure, we will share that. And by the way, this is the link to
Okay.
the Slack. If you want to go and check out the bot, or if you want to ask any other questions about ZenML or LLMs or production environments, this is the best place to be. It's really really active. A lot of people there who answer questions really fast. So this will be there.
So we'll keep this slide for 1 minute until we have more question.
Okay.
All right. I guess there are no more questions. Thank you, Jayesh. Thank you for taking your time and demonstrating the code demo and as well as telling how to build pipelines to run your LLM agent or LLM application in production, and also how to keep track of it, creating versioning and everything around it. I hope you found this session very useful. If you have any doubt or if you have any more question, whether it is related to slide, whether it is related to pipeline or the code demo that Jayesh demonstrated, you can either scan the code and join this Slack. Is it for the Slack or what?
This is for the Slack, yes.
Okay, you can join that particular Slack and ask your question. Yeah, thanks. Thanks again for joining in. Thank you, Jayesh. Thank you for accepting the
Thank you so
invitation.
much. Thank you so much. Thank you so much.